Tornadoes, a phenomenon in weather that few people understand. Dominant in the area of the Great Plains, otherwise known as Tornado Valley, tornadoes have very distinct properties, making itself noteworthy of being utterly destructive. A tornado can also be one of the most fascinating things that Earth has to offer. First of all, how are tornadoes formed? Although it isn't certain exactly how tornadoes are formed, we do have a generalized idea of how they develop. First of all, tornadoes usually occur in Tornado Valley or the central United States. Within this region, atmospheric properties are ideal in generating tornadoes. For example, warm, moist air from the Gulf of Mexico heads north towards the Great Plains, while cool, dry air from the Rocky Mountains head east towards the Great Plains. The warm Gulf air is lower to the ground than the cool mountain air, and are able to interact with each other as a result. As the warm surface area goes in one direction, the cool air above it will go the opposite, making the air between the drafts roll in a horizontal vortex. Once the warm surface area gets warmer and loses density, it begins to rise up into the cool air above it, creating an updraft. This updraft interacts with the horizontal vortex, bending it into a vertical vortex in the shape of a downward parabola. This vertical vortex then reaches the cooler air above the surface and creates a thunderstorm. When the warm updraft pulls warm air through and around the vertical vortex up to the cool air above, resulting in a mesocyclone, which serves as the root of the soon-to-be tornado. As the mesocyclone or wall cloud approaches the ground, so does the rear flank downdraft of the supercell, generating a funnel cloud. The rear flank downdraft continues to approach the ground until contact, where the wall cloud also makes contact with the surface, spawning a tornado. The tornado is then fueled by the flow of warm air into the mesocyclone and once depleted will fade. Although tornadoes do not typically spawn near the Rocky Mountains or other mountainous ranges, or hills for that matter, they are able to if given the right conditions. The main reason why they are not seen in these regions is due to the lack of warm surface air mixing with cool air from above. In this case, only the cool air is found prevalent. It is possible for tornadoes to form in terrain other than the terrain in the Great Plains, such as flat ground, but it is difficult due to not having ideal atmospheric properties or atmospheric instabilities.
When we measure the damage a tornado can do or has done, we use the enhanced Fujita scale, and that's on a range of 1 to 5, and you label as EF1, EF2, EF3, EF4, and EF5. We originally had the F scale until 2007 when we made it another scale more applicable to the tornadoes we have here in the US. So first we're going to look at the lowest severity of a tornado you can have, the first level, also known as EF1. Typically these tornadoes are much smaller. Rarely do they actually touch down and do a lot of damage. But as you can see, they're both still around 86 to 110 miles an hour, which can still definitely do damage to roofs, rip off exterior doors, break glass, tip over mobile homes, etc. The second level, EF2, is a lot more considerable damage. The wind gusts go up for about another 30 miles an hour, and this is when you can actually start having projectiles. So just pieces of wood, shingles, things like that, and actual roofs can be ripped off from well-built houses, so the wind is definitely increasing by this point. By level 3, you're talking about severe damage. You're having wind gusts up to 165 miles an hour. And this is when you can have cars start to tip over, entire floors ripped apart, and even trains have been reported being overturned in EF3 tornadoes. EF4, rarely does it ever get past this point. These are definitely devastating. They can rip entire houses apart, they can uproot large trees that have been established for hundreds of years, and they can rip cities apart for sure. EF5 tornadoes are the worst you can have. They do an incredible amount of damage. They have wind exceeding 200 miles per hour. Usually hail and other weather phenomena accompany a storm like this. They can be up to a mile wide, so they're definitely larger than the rope tornadoes that we see in EF1 and EF2 tornadoes. Cars can be thrown very long distances, even 100 meters, and houses can actually be lifted off their foundations and literally blown away. So here is just a nice representation of the different kind of damage different kinds of tornadoes can do. This is obviously one tornado that had blown through like this, and it just shows that near the eye of the tornado, where you can see the EF5 damages, there are literally no house left behind, even the EF4s. There's at least still debris there. Over here, where the tornado wasn't nearly as close, you can see what an EF2 damage tornado would look like if it had gone right over top of it. You can see parts of the house missing, and over here there's actually no more damage other than maybe a few shingles being ripped off. So that's just kind of a good gradient graphic to see what kind of damage different kinds of tornadoes can do.
History of tornadoes. Tornadoes were unknown to the people prior to the 1800s since there's no record of them, and it wasn't until April 26, 1884 that the first photo of a tornado surfaced, and it wasn't until then that meteorologists started to study tornadoes. And in the 1900s and 2000s, we started to study them more and more as they were happening more often, and the deadliest tornadoes did happen in the 1900s, being one in Bangladesh that injured over 12,000 people. And compared to how often they happened in the 1800s, already in 2015 we have had 700 to 900 tornadoes and 888 in 2014 in just the US alone, which shows that there's more opportunity to study them and learn more about tornadoes.
Forecasting tornadoes and tornado safety. Forecasting tornadoes is extremely difficult as slight changes in the atmosphere can cause drastically different results as far as storm production and tornado formation. The slight differences in scenarios are not currently measurable by meteorologists. To combat this, meteorologists employ ensemble forecasting, which allows for multiple scenario forecasting. If the outcomes of the ensemble forecasting are similar, then the weather will behave predictably. If they differ, the weather will behave erratically. Meteorologists must then rely on past experience and detection to predict what might happen. Tornadoes produce tornado vortex signatures, or TVSs, on radar imagery. They consist of tight rotating wind patterns and will appear inside of mesocyclones. Mesocyclones are larger rotating updrafts and will produce hook echoes on radar imagery. They appear on the bottom right half of supercells. Not every mesocyclone will produce a TVS or a tornado. And if you have a TVS, it does not guarantee that you will have a tornado. This is a velocity radar of a supercell that produced a mesocyclone and a TVS. The mesocyclone is highlighted by the yellow circle, and the TVS is indicated by the red triangle. Tornado safety is pretty self-explanatory. Generally, you'll want to go to the basement or lowest floor possible and get under some kind of sturdy protection. If you can't find any sturdy protection, then a cushion or blanket will help because it can block light debris. If you're in a car, drive away from the tornado in right angles, not directly away from it. Seek shelter in buildings, but not under bridges. If there is no shelter, stay in your car or get in a ditch and lie face down. And if you're outdoors, get away from trees and also lie face down.